Hi guys, I hope you had a good holiday. We are a week behind, so I tried to complete quadratic function this week. So I'm gonna cover section 11, 12, and 13 and 14, this week. Also, make sure you complete your assessment task 4 by Friday. I'll ask you to hand it in by PDF after that, but complete it by Friday. So let's go to section 11, turning point. Now we try to draw it. So we're graphing it for quadratic formula. Particularly, we're using turning point form, which is related to your vertex form, which you learned it last term, vertex form, or they use power form or vertex form. It's all the same thing, or you can say turning point form. Doesn't matter which word you see, they're talking about the same thing, which you got the form here. Before we get into that, I'll go and draw this one. Okay, use the like a linear. Let's think about just draw quadratic equation. Like for example, y equals 2x plus, in this case they use y equals x squared. I'll draw that, okay? And obviously we need to put input, isn't it? Input, and we will get the output. In this case, I'll put x and y, I'll put minus 2. When x is minus 2, what do we get? Y equals minus 2 squared. Therefore, minus 2 times minus 2, 4. We get 4. Y equals 4. So we got the 4. Let's just go one by one. Minus 1, 0, 1, 2. I'll let you do that. Yeah. Can you do that? Can you plug in each numbers? So y equals now minus 1 squared, 1. Can you continue that? I'll just wait a little bit. Okay. You pause it and then you can continue. And you will get 1, 0, 1, and 4. Is it? If I extend it, 3, I'll probably get 9 as well. It's like same way, like linear, When we do linear, we put different points and we linked it. That's how they look like. And we call linear equation. But quadratic, we'll see how they look like it. Let's draw that. X-axis, y-axis. Minus 2, minus 1, 0, 1, 2, 3, or just minus 3. Okay, I haven't done minus 3, but I know minus 3, negative, negative, positive, 3 times 3, 9. So minus 3, I have, 3, 6, 9, up that way. I'll get the 9, minus 2, I have 4, so somewhere here. Minus 1, I have 1. When x is 0, y is 0. The other one's here. 2, 4, because you can see they are symmetrical from y-axis. And 3, 9. So when I linked it, they're not straight line. They now have curve. Then that curve looks like this. So squared number always have this basic form. That's why we start from y equals x squared form, squared equation. Okay, they usually always look like this. Yeah, and this is positive graph. When gradient is positive, you will have what? Well, I shouldn't use the word gradient, but it's an A in front of this. I will talk about it later. So at this point, you need to know, yes, they look like this. Cool? You happy with that? Yeah. And then let's just think about each characteristics here. The graph called parabola. Yeah, the parabola ones look like this, and left and right hand side, they are symmetrical. Okay, they are symmetrical. And another one we can see, okay, for axis domain, they cover whole positive and negative numbers, isn't it? Yeah, they cover the whole thing. However, because this is a squared number, y value, in this case, y value is all positive. Yeah, the y value is whole positive. The range is only positive numbers. Yeah, I can see that one. Yeah. And what else you need to see? Okay, so I talked about they are symmetrical by this line, isn't it? And that invisible line I will call axis of symmetry. Yeah. In this case, y equals 0. When y equals 0, when x equals 0. Yeah. So for the line here, yeah, x equals 0, we have the symmetry left and right hand side. So I'll call axis of symmetry is x equals 0. Yeah. And what else? Okay. When we look at this point, y value was decreasing. When x increased, y value is decreasing all the way through till when x is 0. And after that, y value start to increase. So we call this particular point turning point. So this is a turning point, or we call vertex. That's why you can call this vertex turning point form or vertex form. Yep. In this case, turning point is 0 and 0. 0 and 0. And when equation looks like this turning point gonna be minimum value or minimum y value, isn't it? If graph look like this, that will be the maximum value. That makes sense? Yeah. We check the just y value. Depends on how graph look like it. So we draw that. What about? I'll ask you to draw y equals minus x squared. Can you draw that? Yep. Same thing. We'll use that x and y. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Can you continue? Yeah. hopefully after you spend some of the time, you will get this look like graph. So exactly same, look like basic form. However, since you have the gradient negative in front of squared, squared, you will get the negative. Therefore, we will have flip form the other way. Yeah. In this case, our turning point will be maximum. Yeah. So you can see the difference. So I can write down y equals 2x, y equals 3x. I can see since it's a positive and positive, that will look like something like that. Yeah, the form always look like this. If we have y equals minus 2x squared, oh, it's negative. Y equals minus 3x squared, oh, it's negative. Then that will look like basically this reflected form. Easy enough? Yeah, that's the first thing you can recognize it. So I just covered this whole thing. Yeah, and let's continue this one. This is a summary and more details here. So let's just check one by one. Okay. This is the basic form. So that's the we call turning point form or vertex form or power form. Any word you see, that's what they expect. Y equals, a x minus b squared plus c form. You've seen this before. Where? Let's go back. Factorize by completing the square. Let's go back to the form. Let me do that. Yeah, here. Y equals, okay, y equals x plus minus h squared plus k. That exactly look like what we have here. They just use different letters here, coefficients. Yeah. So let's check one by one. A is a dilation factor. Well, I'll check that later. Leave it that way. And then I'll probably go and do it from here. Okay, next page. Graph of y equals a x squared. The first thing you need to see is that a is positive or negative. If a is positive, we will have this kind of form, isn't it? Yep. And a is a negative, we will have the other way. Use the color the other way. So a is positive, a is negative. That's the first thing you need to recognize it. And then when they call dilation factor, which means now we start to put different value in the coefficient. We'll see how that works. It's the easiest way you can look at this is it's like gradient. Think about y equals x. Y equals x. You know, gradient was 1, isn't it? So now we have this increasing graph. What about y equals, I'll use that. Y equals x. We had this. Y equals 2x. Now we have slightly higher increasing graph, isn't it? Yeah, I'm just drawing roughly. Y equals 3x, increase more. Do you remember that? Yep. Very, very same with y equals x squared. X squared is look like that. We've done it. before. Now we know that. Now, what about y equals 2x squared? When we put in x value here, 1, we got 1. Yeah? When you put 2, it was 4. Can you see that? That's look like this. Now, when we put in 1 x value, 1 times 1, 1 times 2. So y value is twice bigger than this one, the previous one. The y value increased not just 1, but twice. They actually squared and times 2. So y value for the same axis, like 1, 2, 3. Now, when I put 1, 1 times 1, 1 times 2, so therefore this is 2 now. What about 2? 2 times 2, 4 times 2, 8. It's twice bigger as well. So when I link that, I have graph like this. So you will have the graph narrower, or you can use the word narrow or thin. So they use the word narrower or thin, thinner, narrow or thinner, when x value is bigger than 1. Yeah? Well, that makes sense. This is basically, you times it, whatever the value in front of x, the y value increase that much. So if that's bigger than 1, your y value will increase higher level. Like same as this. That increasing value looks like a narrower, isn't it? Same, so it will go up more because y value increase twice more. What about y equals 3x squared? Do you think it's going to move this way or narrower? It's going to be narrower. So when this a value increase, like positive way, we will have thinner and thinner graph. So y equals 3x squared 1, we will have something like this. I'm just exaggerating here, but you can see it's thinner and thinner that way. Do you understand? Yeah? What about negative ones? Same way. Y equals minus x squared. We done it. Oh, it's a negative, so we should have opposite one. Yeah. Y equals minus 2x squared. So negative always just show, oh, it's reflected. So reflected the other way. And then the same thing. We look at that. It's going to be narrower because it changes more sharply. This way. Okay. And y equals minus 3x squared. Narrower. So move towards that way. Does it make sense? Yeah. Hopefully you can see that. So usually first thing I'm looking at it is that positive or negative? Positive, negative, negative, right? Positive, negative. Y equals x squared, 2x, 3x. This way, y equals minus x squared minus 2x squared, 3x squared, narrower. When x is, that's why they write down. If a is bigger than 1, the graph is narrower. That's what they're telling me. Narrower. Yeah? And if a is between 0 and 1, same way with linear. Think about linear since you learn it. If linear was y equals half x, increase only half, wasn't it? Compared to y equals x, halfway. Same way, the number is between 1 and 0, it will be wider, which means it increase slower and slower when that number is smaller and smaller. So in this case, y equals half, y equals third. It's going to be getting, the increasing size is smaller and smaller, and then graph look like wider and wider. That's why they call this wider or broader. Yeah, you can use any expression. So probably the best is just remember narrower or wider. I mean, you can see it. You can see it. Yeah. Hopefully, you will be able to draw this by yourself. You need to be able to do it in your brain. So let's go back to our note. So we call, in general, y equals x squared is similar to y equals x squared, but dilated by a factor of a in the direction of the y-axis. That's how you write down. Or you write down dilation factor is a. In this case, let's say y equals 2x squared, then I can write down dilated by a factor of 2. Make sense? Y equals minus 3x squared, dilated by a factor of 3. Yeah, the dilation factor is just how narrower or wider. And when a is negative, the graph reflected. Yeah, oh, that's simple enough. So if that's negative, I write down dilation factor is 3 and reflected in the x-axis. They used it because it looked like this one, they reflected the other way for the x-axis, from the x-axis. So you have to write it down both. So let's just go back and think about how to write this. Y equals 4x squared, and then I can write down this dilation factor. Dilation factor is 4. Or I can write down dilated by a factor of 4 in the direction of the y-axis. So you can express 2 different ways. Good. And when you have negative a, you can say dilation factor is 4 and reflected in the x-axis. You need to write it down both. Good? Yeah? So can you do this one? Y equals 2 squared. Can you express that? Y equals minus half x squared as well. Can you express it? Yeah, so I'll write down this way. Hopefully you're able to write it down, okay? Yeah. So I check that y equals when a change. A was in front of squared 1. Good? Yeah? And then we checked when a is negative, when a is bigger than 1, when a is between 0 and 1. We checked that, right? I'll just summarize quickly. When A is positive, this looking one, negative, that looking one. When A is 1, bigger than 1, it's going to be getting narrower. Good? Yeah. When A is between 0 and 1, you're going to have a bit wider ones. It's like decreasing that way. Yeah. So hopefully it's the same way the other way. Yeah. And okay, we've done that. On the next one, translation. We'll look at that. Yeah, well, let's check this one first. And then, according to this turning point form, which is completing square form, y equals a, yep, we get that, a, x minus b, x, bracket square plus c. Let's check that one. I'll probably just do all together here. Y equals, we done that x, a, x minus b, they use the b, yep, squared plus c. We covered that part, wasn't it? Yeah, we covered that part, since this basic form was ax, yep. And now we're dealing with that b and c. The b still inside of squared form, so I'll just go y equals a x minus b squared. Let's check this one first. Let's say y equals x squared. When let's say a is 1 in this case, and y equals x, then I'll put minus 1 squared. What's the difference? Okay. In this case, I will have this one, isn't it? We know how to draw that now. Yeah. What about minus 1? When x is 1, y equals 1 minus 1 squared. 1 minus 1, 0, it was 0. So when x is 1, y is 0 here. 1 and 0. When x is 2, 2 minus 1 squared, I got 1. Yeah. When x is 2, I get 1. When x is 3, 3 minus 1 square, so 2, 2, so we got 4. Yeah. So now you can see, if I continue that, keep interrupting. If I continue that, I'll have something look like this. So it's exactly the same. The only difference is it moves how much? 1 right side. Isn't it? The whole graph just move 1 positive side or right hand side. Yeah? Just 1. Can you see that? Yeah. Or you can think this way. The value, y value has the same. Probably the easiest way is you consider that is always there negative. Okay? So whatever the value you have inside, that's how much you moved right hand side. Good? Yeah? So y equals x minus 2 squared. Then without doing it, I can see, oh, that moves 2 right hand side. So 1, 2. So we'll have something like this. Y equals x minus 3 squared. I'll move 1, 2, 3. So I'll have something like this. So you guys happy with that? Yeah? What about the other way? Y equals x plus 1 squared. Now we move that way, opposite way. Okay? Move minus 1. Sounds good? Yep. So it moves x axis move the opposite value. That's probably the easiest way you remember this. Yeah. So I'll go y equals 2x minus 1 squared. All I need to do, the first thing, I'll check A. Okay, positive. So I'll have something like that. This positive looking one. And then 2, bit narrower. Yeah. And then x value moved opposite of minus 1, which is 1. So x value moved to 1 and look like this, bit narrower. So I'll have something like that. That's how I can draw. You happy with that? Yeah? What about y equals minus 3x plus 1 squared? If I draw that, the first thing, you go and look at A first. Minus 3 is negative. So, no, not this way. Yes, that reflected form. Dilation factor is 3, so it's narrower. And then, so we have turning point, maximum turning point here. And, move x value, how much? Opposite of this, minus 1. So minus 1. And narrower, I'll have this. So you're happy with that? Yep. So this is y equals minus 3x plus 1 squared. Now, I feel pretty confident. You know now, you understand how to draw that. Yeah. So just remember, x value moves opposite of whatever the value you have. Yeah. But that's the second thing you need to consider when you draw it. Yeah. Or I guess it doesn't really matter. You can just move first and then draw it. Yeah. And next one, so I just covered that these parts. Yeah, that's what I covered. And let's just go and check that. In general, y equals x minus h. Well, in this, I don't know why I keep changing it, but the number square is translated h unit right. Well, h unit left if h is positive. What? Using right. Oh yeah. Sorry, I talked about that, isn't it? Yeah. So positive. No, negative and positive. Opposite way. We talked about that. And in this case, the axis of symmetry will be changed. What does that mean? That's y equals 2x squared form. Yeah. Axis of symmetry was here. X equals 0. However, if I move y equals 2x minus 3 squared. So x value move how much? Positive 3. 1, 2, 3 here. So now we'll this move to that way. Yep. Translate. They use the word translate. They translate to how much? Right hand side 3, positive 3. 3. Therefore, axis of symmetry is what? X equals 3. That's simple enough, isn't it? Yeah. Doesn't matter how much you move, you just axis of symmetry is moving. That makes sense. I don't think I need to explain that part. The other one, last movement. So I've done y equals a x minus b squared. However, now I can move one more point here. They use the k. Let's start from here. Y equals x squared 1. That's y equals x squared. Oh, it should be wider. Yeah. And I'll compare with y equals x squared plus 1. That's probably the easiest way to introduce that. So y equals x squared, we've done that plug the number. Let's plug the number here. X is 1. When x is 1, y value is 2. When x is 2, 2 to 4 plus 1. Oh, 5. Okay. 3 times 3, 9 plus 1, 10. So you realize it. This value is actually value of x squared plus 1. X squared plus 1, x squared plus 1. I mean, obviously that's what I did. But whatever the value, previously I had 1 and 4, 9. All I done, y value is just 1 bigger than x squared form. That makes sense? That's how you look at it. Y is x squared plus 2. So y value is all the same, whatever I put x, just bigger than 2. So y value is all, in this case, bigger than 1, in this case, bigger than 2. Then if I draw that, all the y value is 1 bigger. Exactly same, just 1 bigger. So that translated this way. That's how it looks like. Make sense? 2. Oh, that's 1. Sorry, guys. This one, 2. 1, 2. That's how they look like. Good. What about y equals x squared minus 4? The y value is same as x squared, but move how much? Minus 4. In this case, it just go all the way down. Minus 1, minus 2, minus 3, minus 4. So they look like this. So I hope you're confident now drawing this one. And the other way, let's think about y equals x squared. Minus x squared. Yeah, let's put negative. Plus 3. Yeah. So now I know this is negative. That good. And then we move how much y value? 3. So we move up 3. So 1, 2, 3. We'll have something like that, which is y equals minus x squared plus 3. Excellent. Good. We're happy with that. Minus 3x squared plus 5. What about that? Oh, yeah, let's put that one. So it's a negative, reflected 1, dilated how much? 3. So 3 is narrower. And then we move y value 5 up. So I'll have something like that. Yeah, I'll just exaggerate it to compare to that. So hopefully you have this idea. Let's go back to your note. Okay, that will explain that. Translated k units up if k is positive. Well, they explained it. Yes, this k value there, it moved vertical direction. The other way, this h value here next to x, this moved horizontally. Well, horizontally 2, horizontally negative 2. You can write that down way. You translate it vertically 2, positive 2, vertically minus 2. You can write it. You can express different way. And all the graph remain unchanged. We've done that. Axis of symmetry is still, yes, we've done that. Well, it only changed y values, isn't it? Yeah, how much move and down. So the axis of symmetry is not going to change. Axis of symmetry depends on this h value when they move it. So let's do this together. I mean, I try to make short video, but this is a bit long and This is a foundation thing, so I'll spend it more time. If you had enough, you can go to the toilet, you can just pause it, yeah, spend your time. It's a bit weird teaching without students, but hopefully you understand what I'm talking about. What about this then? Now I'll just combine this together. Y equals, that's what we learned first, x squared, for example, y is 2x squared, yeah, y equals minus 2x squared. Think about that, yeah. Dilation factor, and reflect it, yeah. And then what we learn is y equals x minus h squared. So example, x minus 2 squared, yeah. This y x squared 1 moved how much? Opposite of this, 2. So it's translated plus 2 horizontally. X plus 3 squared, same thing, horizontally minus 3. Yeah, translated. Y equals x squared plus 4. Yep, vertically move 4. Vertically move negative 5. Yep, I'll put these 3 together, which is y is a x minus h squared plus k. That's what we learned from here. In this case, they use y equals a x minus b squared plus c, or just different letter there. But that's the summary. That's the summary. And I actually already explained the whole thing, but can you go this through? Yeah, that's the summary. And I used actual numbers. We'll think about that. Y equals 2x minus 5 squared plus 4. All together. Yep. I'll let you think first. Okay. Think about one by one. The first thing you need to see, A. Positive, yes, this is positive, look like that. And it's bigger than 1, yes, narrower. Dilation factor is what? 2. So no reflection happen here. And then it moves horizontally, x-axis, how much? 5. Opposite of that, so it's 5. And how much move? Vertically, or y value, yeah, y-axis, positive 4. So that's how much they move. Translated this much. So your turning point now is not 0 and 0. The turning point move horizontally 5, positive 5, vertically plus 4. Yeah. And this one will look like that. That's easy enough for you guys? Yeah. Let's do another question. Can you do y equals minus 3x plus 4 squared minus 3? Can you do that, please? Yep, I'll let you do that first. So now you're able to do it. Let's check first a minus 3, which means this is reflected. from x-axis. Yeah. What's going on here? Okay. And direction factor is 3. Yeah. What else? So now I know this is negative, so not this way, that reflected way, yeah, from x-axis. And then dilation factor is 3, so it's a narrower, good. And then we need to move. So still, if I draw that, it will look like this, isn't it? From, yeah, 0 and 0. So that turning point here, the increase and decrease, that changing the gradient point, we call turning point. The turning point is 0 and 0 now, but now we need to move that. How much? Horizontally or x-axis? -4. Make sure this one moves opposite way, -4 and -3. -4, -3, so we'll have these. Sounds good? Yeah, that's simple enough now. And I indicated this is -4, -3. That's turning point. Yeah, I mean, if I want more accurate graph, I should get, in this case, there is no x-intercept. You can see that, yeah. There is only one y-intercept, so you can actually get y-intercept. How do you get the y-intercept? Oh, we're not doing that yet, but how do you get y-intercept from linear? Y-intercept is when x value is what? 0. So you plugged in 0 in x. Yeah. Then you can get the y value. We'll do that together later. Okay. So we've done that. So make sure you practice these questions here. And then how they write down. They use TP. TP is turning point. Yeah. And axis of symmetry, we've done that. So let's check one by one. So turning point is -1 and 4 x and y value. So I can write down straight away -1 and 4. Good. State axis of symmetry. How much x move? Yeah. X is now moved to +1 is -1, isn't it? -1. So axis of symmetry is x is -1. Good. So in this case, it moves that way. I didn't draw that one, but I just show you that it moves -1. So axis of symmetry is x equals -1. The same as this turning point. Good. And A is 1. So A is, it's not bigger than 1. You know, it's not bigger than 1. I won't use that, this word. Yeah. I'll just say A equals 1. Yeah. So like if it's 2, A is bigger than 0, therefore that's thinner. You just need to write down it's thinner or wider. Okay, narrower, wider. And narrower case, this is 1. Yeah. So x is A is bigger than 1, then you will have something like that. Yeah, isn't it? Graph is maximum. Well, obviously this reflected one. So when you look at it, that's obvious. Y value in this case, that turning point is maximum y value. Yeah, when they say maximum, the turning point is maximum y value. The maximum value happens when A is negative, because they look like this. So you got the maximum point top here. What about the other way? When A is positive, you will get that. So your turning point here is the minimum value for y-axis. And okay, y-intercept and x-intercept and y-intercept. X-intercept is when y is 0, y-intercept is when x is 0. I think you can do that. Yeah, you will get that. I'll actually do it in the question. Okay, but all you need to do, but in this case, you draw first. Okay, -1 and 4, -1 and 4 here, and it's a negative reflected, yeah, and 1, so I'll have something like, roughly we'll have something like this, isn't it? Yeah, but I'm not sure that points, I'm not sure that y-intercept and x-intercept, because we haven't got that, but I know it's something look like this. Yeah, and then all you need to do, how do we get the y-intercept here? When x is 0, when x is 0, plugged in, y is what? 3. So that's 3. So you can indicate that. You can indicate this is turning point, TP is -1 and 4. And that value will go x-intercept, therefore y is 0, you plug in, you will get the 2 value in this case. You can see that it's obvious you get the 2 value, 1 and -3. So you indicate that as well. That's how you draw. That's complete. Sounds good? Let's move on. Okay, I'll let you do example 1 and 2, 3. Yeah, 1 and 2, 3. I mean, you have I upload the solutions already. I mean, I'll do that together, but you do it first. You do it first by yourselves, and then watch this video. So you can pause it and do first, and watch this video. Okay, let's do this together. To convert the function y equals x squared minus 6x plus 1 into power form, which is same as what? The text form or turning point form. Same language, okay? So don't worry about that. How can we convert this to power form or in turning point form or vertex form? Completing the square. Excellent. Imagine I'm in front of you. We just try to mimic our class. State the coordinates of turning points. You get TP and axis of symmetry. Good. And any x-intercept. Okay. Well, I think we can just draw the whole thing. Okay. We'll just practice. In this case, y equals x. What is half of -6? -3 plus 9 -9 plus 1. Do you remember that? Yeah. If you forget this part, go back to your turning point and think, yeah. And then squared. X minus 3 squared minus 8. So done. I convert to power form or vertex form or turning point form. I've done it. Now I can deal with that. A is 1, easy, okay? Positive, so we'll have something like that. And how much they translated? X horizontally, 3. Y-axis or vertically -8. That's how much they move from 0 and 0 origin. So TP turning point gonna be 3 and -8. So if I draw that, we'll have something like this, yeah, and move x value 3 and minus y value minus 8. So 3n minus 8 will have something like this. I'm not sure that value exactly because I didn't draw very well here. And then, so in this case, what I can see is coordinates of turning point. I've done that already. Axis of symmetry, you can see from here. So axis of symmetry is x equals 3. How much x moved? You can actually see it straight away, so you can answer both. And then any x intercepts. So in this case, they're interested in this. I mean, I don't know if it's negative or not yet. We're just rough drawing, okay? But I can see we will have definitely what? X intercepts. X intercepts. How can you get the x intercepts? When what? Y equals 0. Good, guys, good. When y is 0, you can use that. What is it? X minus 3 square minus 8. Yeah. X minus 3 square moved 8. X minus 3, get rid of the square, plus minus square root 8, good. And I want to know x value, so x equals plus minus 3. So we move that way, yeah. So therefore, x equals 3 plus minus 2 root 2. There are two values there, isn't it? So 3 plus this, or 3 minus that. So that is going to be 3 plus this. Yeah. And that is 3 minus this. That's a negative value. Because root 2 is 1.4. Yeah. Something there. You happy with that? Yeah. So either you express two different ways. So I get turning point value, and from the turning point you can get axis of symmetry directly. And then whatever they ask, what about the y here? Y intercept. When x is 0, I can put in either here or that. 0, 0. Oh, it's actually 1 then, isn't it? 0, 0 plus 1. So y-intercept is actually 1. Yeah. Oh, so it should draw this way. Yeah. But that's not they ask here, so I'll just move on. Example 2. Y equals, okay, now we have 2 here. Yep. We're using completing square. We don't deal with that. We have to make a 1, isn't it? So 2x squared, that's the easiest way you can do, and half x minus 2. Are you happy with that? Yeah. And then 2. What is half of minus 1 over 2? X minus half, yeah, times 1 over 2, and then square, minus, always, square that, 1, 1, 1, 4 times 4, 16, minus 2. You happy with that? I mean, probably I'll do it once next time, but 2 x minus quarter square minus 16, 1 minus 2 is times 2, 32. 30 minus 32 divided by 16 is minus 2. Okay? So it's algebra, I won't go there. 2 x minus square minus 16 30 hold on 3 yeah, probably not the best way to write down that way. Okay, that looks a bit easier. It's the same thing, but that probably looks much easier. Or I'll probably write down this one is 32 16. Then all you need to do is this. Yeah, minus 1 minus 32 minus 33. Happy with that? That's probably easier to look at it. And then now 2x minus quarter square minus open the bracket 33 8 cancel things out. So try to make that form, yeah, using algebra method. Okay, we're using algebra method, and they ask turning point. Therefore, turning point is 1 over 4 minus 33 over 8. P equals that. Happy with that? So the turning point, when you have turning point question, all you need to do, completing the square. Simple enough, completing the square. If you have number in front of that, you just put one side, and then you complete the square, and then open the bracket. Then you will get actual form there. Okay. Good. Next. I'll just this really quickly. I mean, you got the solution there. So when you look at it, all you need to do, A is minus 3. So this is what? Reflected. Yeah, this is reflected. And dilation factor is 3. And move x horizontally or x-axis how much? Opposite of this, minus 2. And vertically, minus 5. Turning point, so minus 2 and minus 5. Yeah, and then you can draw that. Turning point is minus 2 and minus 5, and this is reflected, so this, and dilation factor is 3, so go that way. So I'll have something like that. Do we have any x-intercept? No, all I have is y-intercept. How can I get that? When x equals 0, when x equals 0, so here 0, y equals minus 3, 0 plus 2 square minus 5 minus 3, 0 plus 2 is 2, 4 minus 5, minus 3 times 4 minus 12 minus 5 minus 17. That's minus 17. That's all you need to do. So you try to indicate intercepts, but in this case we only have y-intercept. Okay. And order of transformation. You basically start from x. That's probably the easiest way. I mean, they write down the order here, but if I do that, the easiest way, you start near x and then you expand it. In this case, from the x, okay, near the x, you go, like, because the basic form is y equals x squared, so you start from x. How much horizontally they move? H. Yep. So you consider this shift first, and then, so I'll just write down y equals fx same as y minus 2 x minus 5 square plus 10. Let's deal with that. Yep. So first your move is this. So translated 5 units right. Okay, that's one of the way you can express that. Yep. and then start from x, and then we complete this. Reflect it, yes, negative there, so reflect it in x-axis, good. And then how much dilated? 2. Dilation factor is 2. And then translate it vertically, 10. Sounds good? Yep. So you start from near x and expand it. That's probably the easiest way to remember this order. So you can continue that. I'll just do one question with you. It's all there. Start from here. Horizontally, right and move -5, and then reflect it. Dilation factor is 4. Vertically move -3. Sounds good? And then, so you can write it down as that order. Yeah. Also, I can draw that. Okay, then -5 -3. That's TP. I'm just showing you the whole thing, not this question. I just want to draw it, graphing, and that's negative, narrower, -4, therefore -5 -3 here. I'll have that. All I have intercept is what? Possible y-intercept when x equals 0. We can get that. So we can draw that. So example 5, you can do that. So move horizontally -6, move +1. So the turning point is -6 and 1. Yeah. Oh, sorry, I should follow the order. Yeah, I'll do that first. So horizontally 6. Any reflection? No, there is no reflection. Yeah. And dilation factor is 2. And then you go here, just start from x and spread. Vertically 1. Translated. Sounds good? So you can write it down. You can use that, or you can follow that answer way. Doesn't really matter. And then I'll just draw that. Turning point is -6 and 1 here. All I have is y-intercept. Yeah. So y, and you indicate turning point is -6 and 1. Therefore, axis of symmetry is x equals -6. Yeah. And there is no x-intercept. All I have is y-intercept. When x equals 0, you plug in y equals 2, 0 plus 6 square plus 1, 2 times 6, 36 plus 1, 72, 73. So that's 73. Okay. Simple enough? Yes. Next one. Everything is the same. Draw the graph. Oh, that's positive. 3, narrower. Move 3 and -5 here. You happy with that? Yeah. And then I have something like this. 3 is quite narrow, so I'll draw. It will be something like that, but I actually don't know this will go that or pass this way. True, isn't it? Yeah. So I need to get y-intercept first. Yeah. Go and check y-intercept and x-intercept. So y-intercept, I'll draw that later. depends on y-intercept. Y-intercept is when x equals 0, x equals 0, y equals 3 times 0 minus 3 square minus 5, 3, so it's 3, 9, minus 5, 27, 22, so it's 22. So it will look like this. Good? Yeah. And then you can get x-intercept when y equals 0. Well, they don't really say I need to get that, did they? Let's go to the solution. Did they get that? Yep. Just follow that. You plug in, they actually get 3 plus 3 or 3 minus. So that value here, this value there. Symmetric, yeah. So I indicate this, x-intercept, y-intercept, turning point 3 and minus 5. All I haven't done is give domain and range. Domain is x value belong to real number. So domain in this case, always x domain, yeah, is whole thing, because they didn't really indicate anything. I can expand it to negative infinity and positive infinity, either way, yeah. And when you use the infinity, you use that bracket, because we didn't define it, okay. Exclude 1, and then range is about y value belong to real, and then you go positive way, it goes forever, isn't it? It goes forever, so same thing. However, what's the minimum value? In this case, you know, we look like that, we got the minimum value, which is minus 5, isn't it? Minus 5. We include it? Yes, include. Simple enough? Yep. If we have the graph like that, we'll probably have negative infinity, excluded, and then whatever the turning point here, y value is going to be here. Sounds good? Okay. Make sure you try that. Yep. You need to know how to use that. So, and going back to our first page, turning point form here. Make sure you complete that as well. Okay, I know you will be quite busy, but I'll do it fast like this week. I'll give you a bit more to do. But the other parts is actually quite simple. I mean, it looks like a lot, but it's not. Yeah. As long as you cover what you learned today, probably have good basic here. Sounds good? Yep. So definitely this week I will finish this quadratic function, and then next week I will start next one, cubic. We are like 1 week behind, but when you come back, I think we got time to catch up. So don't worry too much. I'll probably finish my class here today. Yep. Hope you understand. If you have any question, please email me, or you write down, take a photo, yeah, and then send to me. And if many students ask some particular questions, I'll answer that, and then make video and upload it. All right. Thanks, guys. We'll see you next chapter.